Welcome to Unstuck. Today's challenge, the longest substring without repeating characters. Given a string, find the length of the longest run where every character is unique. We'll write the obvious brute force version, see why it's slow, then rebuild it as a sliding window that solves it in a single pass. In Rust, beginner friendly, every step on screen. Here's the whole solution we're building to in Rust. Two functions, a brute force one that's easy to reason about, and a sliding window one that's fast. By the end, you'll understand exactly how the fast one works, line by line. This pattern, the sliding window, shows up everywhere in coding interviews, so it's worth truly getting. If this helps, a like really does too. Let's start with the slow but obvious approach. First, the problem itself. We're given a string like a BC, ABC, BB. We want the longest stretch where no character repeats. Here that's a BC, length 3, because the next character is another A, which would repeat. We just return the length 3. So here's the key idea as a picture. We keep a window, a left edge and a right edge over the string. We push the right edge forward one character at a time. As long as everything inside is unique, the window grows. The moment the new character is already inside, we jump the left edge forward just past that earlier copy, so the window is unique again. The answer is the widest the window ever got. Now the brute force version, which just tries everything. For each starting position, we walk forward, marking each character we've seen. The instant we hit one we've already got, this run ends. So we track the longest run across all starting points. Simple and correct, but look at the shape, a loop inside a loop. And that's the catch. For every starting position, we might walk almost the whole string. That's n starts times up to n steps each, so order n squared. We keep rescanning the same characters over and over. On a short string it's fine, on a long one it crawls. Let's fix that. Here's the sliding window. We remember for each character the last index where we saw it in a hash map called last. We keep a left edge starting at 0 and the best length so far. Now we move the right edge across the string just once. So this is the heart of it. When the character at the right edge was seen before at some position P and that P is inside our current window, we jump the left edge to P plus 1. That instantly drops the earlier copy out of the window, so everything inside is unique again, and we never had to walk backwards. Then we record where we saw this character and update the best length. The current window is right minus left plus 1. That's it. Each character enters the window once and leaves at most once, so the whole thing is a single pass. Let's run it on a handful of cases, printed here on screen. Our main example gives 3, a string of repeated letters gives 1, and the trickier inputs still come out right. And notice the brute force and the sliding window agree on every single case. The window version is just doing it in one pass instead of many. Side by side, the brute force is order n squared, rescanning for every start. The sliding window is order n because each character enters and leaves the window at most once. The trick is the map. It remembers where we last saw a character, so we jump the left edge instead of walking backward. Same answer, far fewer steps. Let's recap. Keep a window with a left and a right edge. Push the right edge forward. Whenever the new character repeats, jump the left edge just past its last position. Track the widest the window ever gets. With a last seen map, that's a single pass, order n, and it beats the brute force order n squared every time. A quick note, if these breakdowns help you level up, the wallet is on screen, and there is a Ko-fi link in the description. Every tip funds the next one. Thank you. Your turn. Comment the problem you want next, and I'll build it just like this. If it helped, hit like and subscribe for more Rust, and remember the sliding window, it's one of the most useful patterns you'll learn. Thanks for watching, and I'll see you in the next one.